Hello everyone, my name is Ritesh Khole and our today's topic is metal catcher. But by hearing this, you may think of magnet? Of course, because magnet attracts the metal towards it. But today we are not going to talk about the regular magnet or the permanent magnet. Today we are going to talk about electromagnet. So, starting with it, when electric current passes through a copper wire, it produces a magnetic field perpendicular to the direction of current. Now, this is a basic phenomenon in which moving a current moment produces a magnetic field. Let us see it through an example like we have wire. Let's say this is a wire. Let me just draw it in a straight way. This is a straight wire, and now imagine the current is moving from down to up. Okay, sorry for that. The current is moving from this direction or down to up direction. So now it generates a magnetic field around this wire. But on which basis can we think of the magnetic field would be generated, or let's say in an anti-clockwise or in a clockwise direction? So for that we have a right hand thumb rule, which is like hold a current carrying conductor in your right hand. So I have a wire with me over here. Then considering this wire have current, so let us consider this wire have down to up current moving. And now place your right hand thumb in the direction of current moving in the wire. So for our example, we have considered the current is moving from down to up. So my thumb would be in up direction, and the remaining finger, if we curl it around the conductor, that will show us how the magnetic waves around the conductor would be generated or in which direction. So in my perspective, it is in anti-clockwise direction. So this is the same example we have considered. So now we can say that the magnetic waves generated using the electric current is in the anti-clockwise direction in this way. And of course, if the current is reversed, like from up to down, now let me just make a line, another line straight down, and then this time we have up to down current moving. In this case, applying the same phenomenon, my right hand thumb would be in the downward direction because our current is moving from up to down. So moving down. And now if we curl this finger around, so it will give me a direction clockwise to the wire. So here we can say these are of course the circular wave. These are around the conductor, okay? It's not over the conductor. Imagine it in a 3D way. So, and this time it will be in a clockwise direction. So, this is how it differ, or we can say the moment of current changes the direction of a magnet or electromagnet around a conductor. But this is not powerful enough to attract something. So, that's why for making an electromagnet, we wound the wire around a metal and passes current through it. So now, in this condition, we make a, let us take a straight conductor. Let's say this is a conductor. And this time we have a wire wound like this. Let's consider now this is from behind, so this is on front. So this is a coil like structure, and we are generating it, or we are moving it in a circular way across the full iron core, let's say. And now this is the end. So now, by creating a potential difference across these wires, let's say here it is a plus and here it is a minus, by simply connecting it to the battery, we can generate a electromagnet, and those waves can travel like this. You might have studied in this in your schools. So these waves are this. Now, these make sure that these waves do not touch each other because they don't intersect at any point. Now, this is not possible to correctly show right now. So you can, and of course, here is it is not an intersection. Just they are in a proper shape, and similarly, these are on bottom side as well. So there is overall generation of magnet, and this will work similar to a bar magnet, as if having a north pole and a south pole, and thus waves moving from north pole to south pole in this fashion. So this will work in this similar way. Just the difference is this is a permanent magnet and this is a electromagnet. And benefits of electromagnet over a permanent magnet, we can also consider that if we want, we can increase the magnet's intensity or pulling force if we require, which we cannot do in the permanent magnet. This is a main beneficial thing of electromagnet. And yeah, this is how it is done. More the current, more powerful would be the magnetic field. And of course, magnet attracts metal. So let us have an experiment. So we will require a 1.5 volt cell, a screw, a long nail with, what is this? We can see just a nail. Then we have a copper wire, some small metal pieces, very small, which should be attracted with small forces as well. Then we have electronic tape, or we can see a black tape, insulation tape. Now the procedure is wrap the copper wire around the long nail to form a set of circular rings. Yes, as I just show you, we just have an electric, we can say a bar over there, iron bar, and now we have a nail. So let us consider this as a nail. Okay, so we will have a copper wire wound around like this, and then here we have two terminals of that copper wire. Got it? And then what is it? Make this, connect the two ends of copper wire to the two ends of the cell. Make the small metal piece around the long nail. Place the small metal pieces, and then make a note of all your observations. So now when we will connect this to, let's say, potential difference as we have created earlier, so plus and minus, now you can think about that it will be an electromagnet, so it will generate its wave like this, like this, like this, and like this. So when the small pieces are put in, it will be directly get attracted towards this, or they will align themselves according to these direction. Okay, so if they are very small iron fillings, then they will align themselves in this manner, we can say, and they all would be like they are very small, but every small filling would uh, would be in this same fashion or the same electromagnetic field, and that will show that electromagnetic uh, lines, magnetic lines. Now, the flow of electric current through the copper wire generates a magnetic field. That's correct. Now we have seen how that is correct, or what is the phenomenon behind that. I've shown you how can we determine in which direction the magnetic field is, like in clockwise or anti-clockwise, depending on the direction of current. Then this magnetic field attracts the metal pieces towards it and acts like a magnet. Now, here's a think time, and this is an interesting question. Discuss how the high-speed bullet trains run in Japan. So now we may hear regularly that Japan have achieved the highest speed in railways, which is I guess 600 kilometers per hour. So that is the top speed of their bullet trains. So how this happens? Because our trains cannot go fast that much in India right now. So the phenomenon behind that is they just uh, examine think like these are the routes of their trains, and this is the train's base kept upon this rail route. Now, what they does is they have an electromagnetic mechanism inside this, which when passed when the current is passed, it will lift the this train's base slightly upwards. So in that condition, we can imagine it to be like this. Now this is the railways route, and now this is the train's base. So here now they have an air gap which significantly reduces the number of friction generated between the train track and the base of the train, or we can say wheelbase of the train. And now that is in air, so it will produces a negligible resistance to the train, and that's why when in a motion they create such a thing. Like now imagine if this is the, we'll now count at a big scale. So if this is the base of the train, and they have generated electric, or we can say the magnetic moment, and that's why this is in air. Now they due to some algorithms they use, when and due to which the train is moving forward, or the magnetic forces generated is moving ahead, and that's why the train is also moving ahead. And since it is electricity, it can be done very quickly, and that's why the train has achieved a speed of 600 kilometers per hour in Japan. Now, moving towards our next question, what will happen if you increase or decrease the number of circular rings around the long nail? Now, I've given the example like long nail. So, imagine what would happen if we just increase or decrease the number of rotations around this. So, this will basically, and basically we have, if the more number of rotations of coils are there, more number of wire is wound around the nail, the more number of what we can say, more magnetic fields would be generated, and more will be the strength of this electromagnet, and that will basically and that's why it will basically differ the number of power of that electromagnet. So thank you everyone, and if you have any questions you can put it in the comments. I'll definitely try to answer them. Thank you.